thing. Yeah. So, and please mute your mic. Someone has unmute their mic. Yeah. Thank you. So let us start with the day 7 of digital design. Okay. So in today's session, we will see two main concepts. One is sum of products and product of sum. So Boolean functions or logical functions are generally expressed in terms of logical variables. So any Boolean expression can be expressed in two forms. One is SOP form, that is sum of products, and POS form, product of sum. We feel that this will be a easy concept, right? So but this is a very confusing concept also. Okay, so we generally focused on the advanced topics. We will deal with FSM, everything we will deal, but we generally forgot this particular concept. Okay, so I suggest that please revise all these basic concepts. Okay, so these are also very important in terms of interview point. So let us start with the sum of products. What is meant by sum of products, we will see. So in Boolean algebra, a product term is the product of literals or Boolean variables. In logic circuits, a product term is produced by AND operation with no OR operations. So some of the examples of SOP are AB, A dot B, or you can say A B bar, or you can say A B C bar. So A B bar and A B C bar. So these are the some of the examples for our some of the product terms. These are basically product terms, and when we are adding these product terms, then we will get SOP form. So this is nothing but your SOP form. So these are our product terms: BC, AB bar, BC bar. So these are all our product terms, and we are adding this. So that is your SOP form. So this particular function is nothing but this particular Boolean function is written in your sum of product terms. Okay, you are basically adding your product terms. So when two or more product terms are odd or Boolean addition, the resulting expression is known as SOP form. So this form is also known as, you can note down this DNF form. Okay. And some examples of SOP form are written here. So y is equal to AB plus ACD plus B bar C, or y is equal to B plus AC plus AC bar D. So these are all sum of SOP form. Okay. So these are all written in the form of SOP form, sum of product terms. Is it clear for everyone? The SOP form, is it clear? What is meant by SOP form? Is it clear for everyone? Yes? Is it clear for everyone? No. Coming to product of sum terms, here we are going to and our sum terms, okay, or we are going to multiply our sum terms. Okay, so these are our sum terms: a plus b, a plus b bar, a bar plus b plus c. Okay, so in Boolean algebra, a sum term is the sum of literals or Boolean variables, and in logic circuits, a sum term is produced by OR operation with no AND operation. And some of the examples of the sum terms are these. And if you want to write SOP form of this particular representation, so this is our, sorry, if you want to write our POS form of representation, these are our POS form of representation. Product of sum, we are making product of the sum. Okay, for example, B plus D bar into A bar plus B plus C bar into C plus D bar plus C. So these are all our product of sum terms. And when two or more sum terms are multiplied or ANDed, the resulting expression is a product of sum. And this form is also called as conjective normal form, or CNF. And some examples of this product of sum form are this. Okay, so this is how you are going to represent your POS form and SOP form of representation. So if you have any Boolean expression for representing that particular Boolean expression, you have two forms of representation. One is SOP form of representation, and another is POS form of representation. That is sum of product terms and product of sum terms. Okay. Now, so let us see the standard or canonical SOP form. Okay. So let us see one by one. We have standard or canonical form of SOP form, and we have standard or canonical form of POS form. First, let us start our discussion with standard or canonical form of SOP form. Sir, what is this standard or canonical SOP form? So if each term in the sum of product form contains all the variables or literals, then the expression is known as standard sum of products form or canonical form. For example, let's have a design like this. Let's say this is our design, and this design has, let's say, four inputs: A, B, C, and D. Okay, and this is our output, which is a function of A comma B comma C comma D. So our output is dependent upon our inputs. So our output may consist of this particular variables. So our output y of A comma B comma C comma D. The expression, let's say, if it is in sum of product terms, right? So let's say AB plus BC plus CD. Okay. So this is in which form? SOP form or POS form? It is in SOP form. Now, whether this particular equation, the Boolean expression, is consisting of all the literals, all the variables, whether this particular output expression is consisting of all the literals, A, B, C, and D, yes or no? No. Okay. So this particular SOP form is not consisting all the variables. So can we say it as a canonical form or standard form? Can we say whether it is canonical form or a standard? No. Okay. So if each term in the SOP form contains all the variables or literals, then only it is known as standard sum of products or canonical form. What is the example then? Y of A comma B comma C comma D, which is nothing but A B C D plus A B bar C D. You can say anything. Okay. So each product term consists of all the variables or not. Each product term should consist of all the variables, all the four variables. Then only it is called as standard sum of product or canonical sum of product form. Okay. So if each product term consists of all the variables, then only it is known as standard or canonical form of representation. Canonical form of SOP representation. Is it clear for everyone? Yes or no? Is it clear? Yes or no? Yes? Is it clear for everyone? I'm getting only few responses. Yes. Now, Now my question is, let's say we have a particular circuit, or according to the behavior, we have derived this particular Boolean expression. According to a particular behavior of this particular design, we don't know the internal circuitry. We don't know the internal logic diagram of this particular design. According to the behavior, we have somehow given the Boolean expression. Let us say y of a b c d is equal to a b c d plus a b bar c d bar plus a bar b c d bar plus a bar b bar c bar d bar. Okay. So according to the behavior of the particular circuit, we are deriving a Boolean expression. Okay. I don't know what is inside that particular design. According to the behavior, I'm deriving this particular Boolean expression. According to truth table or something, I'm deriving the particular uh, Boolean expression. Now tell me, this is my sum of product term SOP form. Okay. And it is a canonical form. And it is in canonical form or standard form, you can say, or standard form. Now tell me, can I use this canonical form or standard form for building my logic circuit? Can I use this particular canonical form or standard form for building my logic circuit? Yes or no in the chat box. Can I use this particular canonical form or standard form of Boolean expression for building my logic circuit? Yes or no? Can I use that particular canonical form or SOP form for building my design, my logic for that particular design? Yes or no? Yes, yes. We can build, but Is it recommended to build? Is it recommended to build our logic? Is it recommended to build our logic with the canonical form or SOP form? Is it recommended to build our logic using canonical form or standard form? I'm getting only few responses. Please participate, guys. Then only you can remember the concept. Okay. So why you are getting the answer no? Why we can't use this particular canonical form or SOP standard SOP form? Why we can't use this in building our logic? Why it is not recommended? Anyone any answer? Yes. So if we use this particular canonical form or SOP form, then can I say that I can have more number of gates? I can have more number of logic gates, I can say? Yes? Yes or no? So if I use this particular canonical form or standard SOP form, I can say I can have multiple logic gates or my design will be complex. So what happens if the design get complex? What happens? I'm a very good design engineer. I can build multiple complex circuits also. There is no issue. Then what happens? If someone is a very good designer, yes, power and area, very good. Power consumption increases. More power consumption takes place. Okay, more the number of gates, more consumption, cost and time. Yes. Okay. So this and all we should keep in our mind, and that's why we are going to learn Boolean algebra simplification techniques and key map techniques in our upcoming sessions, so that we can simplify our particular Boolean expression. Is it clear why we are going to learn all these methods? Why we are going to learn key maps? Why we are learning Boolean simplification techniques? Everything is it clear? So everything is related with your hardware. Okay. So is it clear for everyone? The motive is it clear? Please respond in the chat box. Yes. Yes. So that was about your canonical SOP form. Okay. Now coming to one more concept which is known as minterm. So each of the product term in the standard SOP form is called as a minterm. Okay. So where is your standard SOP form? This is your minterm, and this is also your minterm, and this is your minterm, and this is your minterm. So remember this, each of the product term in the standard SOP form, each of the product term in the standard SOP form. Like let's say suppose if you have y of a comma b comma c comma d, and if you have abc plus a bar bd, then can you derive the minterm from this? Can you derive the minterm from this? No, right? So please remember, minterms are the product terms in the standard SOP form. Okay, minterms are the product terms in the standard SOP form. Okay, not in normal form. Now, so a n variable function can have in all 2 power n minterms. So a minterm is equal to 1 for only one combination of variables. For example, if we have let's say a, b bar, c, d bar, when this particular a, b bar, c, d bar will be equal to 1, that is a is equal to 1, b is equal to 0, c is equal to 1, and d is equal to 0. You can substitute this, then it will be equal to 1. Okay. And one more thing, if we have a output function y of a comma b comma c comma d, which is of 4 variables, then how many minterms are possible for this particular function? 16. Others? Yes. So please remember the formula. So for a 4 variable function, for a n variable function, for a n variable function, how many minterms are possible? 2 power n minterms are possible. 2 power n minterms are possible. For n variable function, we will have 2 power n minterms. Okay. Now, so for a 4 variable function, we can have 16 minterms. Okay. So let us see this minterms. So this is our 3 variable function. So total it will have 2 power 3, which means 8 minterms. Okay. So if it is 0, 0, 0, and minterms are represented in small letters. that is m naught, small m, okay, small m1, small m2. And here the suffix 0 represents the decimal equivalent. This is decimal equivalent of that particular binary number. That is, what is the decimal equivalent of 0? 0 only. What is decimal equivalent of 010, which is nothing but 2. That is written here. Okay. And minterms are represented in small letters. And in the case of minterms, zeros are represented in complemented form and ones are represented in normal form. Okay. Let's say if you have 000, how you are going to write the minterm? It is nothing but a bar, b bar, c bar. And if you have 001, then the zeros are represented in complemented form, followed by 1 is represented in normal form. Is it clear for everyone? Yes or no? How to write a minterm, is it clear? Please remember, in the case when we are writing the minterm, we are we are considering the complements for zeros and we are writing normally for ones. Okay. Yes. So this is how we are going to write the minterms for a three variable function. We have total m0, m1, m2, m3, m4, m5, m6, m7. Okay. So instead of writing a bar, b bar, c bar, we are just simplifying the writing. That's it. So a bar, b bar, c bar, we can write this as m0, and a bar, b, c bar can be written as m3. Like this, we are just simplifying the writing. That's it. Is it clear for everyone? Yes. Yes. Now, let's say if you have a minterm M7, then what is the Boolean expression we have? What is the equivalent of this M7? Yes, ABC. Okay. 111, or you can say ABC. Yes, correct. Correct. Now, so we can also represent this particular minterms using the sigma notation. So this notation is used to represent sum of products or Boolean expression. So let us have this particular three variable function, which is nothing but a bar, b bar, c, so on. Whether this is canonical form or normal form. Yes, we need truth tables. Yes. Whether this is canonical form or normal form. Canonical form. Okay. So for this canonical form, we are going to write the minterms. Uh, One more question. We need truth table to write all the minterms. No, like I was said, right? So if you have a three variable function, so for that particular three variable function, there will be total how many minterms? 2 power 3 minterms. Then you can simply write all the minterms from m0 to m7. Am I right or wrong? Yes. So if you have a four variable function y of a comma b comma c comma d, then you can simply write all the minterms which are present for that particular variable. So there will be total 16 minterms. What is the use of minterms and max terms? Yes, we'll come to that. Okay, we'll come to that. Now, here, remember one thing, minterms are not nothing extra special case. They are alternate representation for this particular representations. If we have a bar, b bar, c, what is the minterm of this a bar, b bar, c? What is the minterm of a bar, b bar, c? A bar, b bar, c, m1. Okay. So instead of writing a bar, b bar, c, you can write simply m1, right? Am I correct or wrong? Small m1, not capital M1, small m1. Yes? No. So, if you have the function, let's say uh, f of a comma b comma c, this is your function, which is nothing but a bar b bar c bar plus a bar b c bar plus a b c. Now, this particular function can be written as m. What is this? 0, comma, sorry, we can write it as sigma m naught plus We can write it as this is nothing but M2 plus M7. So this is one representation. Okay, there is no sigma here. M0 plus M2 plus M7. Or you can write sigma 0, comma 2, comma 7. That's it. So these are the alternate representation. Yes, correct. So these are the alternate representations of that particular Boolean function. Okay. So we are discussing about the POS form of POS or SOP form. What we are discussing? SOP form. Okay. So in the SOP form, we have minterms which are represented in small letters. Okay. Now let's go to the standard or canonical product POS form. So in the case of POS form, if each term of the product of sum contains all the variables, then the expression is known as standard product of sum form or canonical form of representation. Let's say if we have f of a comma b comma c, which is nothing but a plus b plus c bar into a bar plus b bar plus c bar into a plus b. So whether this is standard or canonical form? Whether this is standard, whether this is canonical form or it is normal form. It is not a canonical form, right? Yes, yes. Okay, correct. So can we write? So in the case of POS form, we have max terms. Okay, in the case of POS form, we have max terms. So can we write the max terms from this particular equation? Can we write the max terms for this particular equation? Can we write the max terms from this particular equation? Okay, let me take min terms only for you. F of a comma b comma c, which is nothing but a ab plus bc plus ac. Whether this is standard or canonical form, sorry, whether this is canonical form or normal form. Please be online. 1 minute, my laptop charging is low. 1 minute, let me insert the charger. 1 minute. Yeah, sorry for that. Now, so yeah, most of you are correct. It is normal form. Now tell me, can we write the minterms from this normal form? What are the minterms here? Can anyone answer? What are the minterms? Can anyone answer? See the question. What are the minterms? Can anyone answer? No, we cannot write the minterms from the normal form. Minterms can be written from the canonical form or yes, standard form. Okay. Minterms should be, yes, we have to convert to the canonical form. Correct. Okay. So if it is not in the canonical form, we should convert it into canonical form, and then only we can write them in terms. Okay. If it is not in the canonical form or the standard form, then we cannot write them in terms. In the definition also, you can see. So each of the product term in the standard SOP form, each of the product term in the standard SOP form is called as a min term. Is it clear for everyone? Yes or no? Please confirm. Now, can you write the same max terms for a normal POS form? If it is a normal POS form, not a standard POS form, can we write? No. We should convert it into canonical form, then only we can write it. Okay. Yes. Very good. Very good. Now, so each sum term in the standard product of sum form is called as max term. Each sum term in the standard product of sum is known as max term. Okay. And these are represented in capital letters, capital M. Okay. And yeah, so these are the max terms. If you want to write the max terms, this is how you are going to write your max terms. 0, 0, 0 can be written as a plus b plus c. So here for 0 we are not going to write the complement, and for 1 we are going to write the variable as in complemented form. Okay, please remember the difference. For 0 we are not going to write the complement, and for 1 we are going to use a complemented representation. Is it clear? Is it clear for everyone? Yes or no? Please acknowledge. Okay. And similarly, if we have an expression like this, a plus b plus c into so on, this we can alternate. What we can do, we can write it in the form of max terms. M naught dot M4, not plus. Okay, M naught, because it is a POS form. We are going to use dot M naught dot M4 dot M6 dot M7. Okay. Yes, here we use capital. Very good. Okay. So this is how we are going to represent our min terms and max terms, and we are going to use our standard SOP form or standard POS form. Okay. So these are the representations, and in our next session, we will see how to convert SOP form to POS form and POS form to SOP form, and how can we simplify this SOP form of expressions and POS form of expressions. Okay. So what are the techniques we have? Can anyone tell me what is the easy technique we use? And also we use pipe. Yes, correct. Yes, K-maps. Okay. So using the K-maps, the simplification becomes easier. Okay. Yes. Yes. Okay. Yeah. So that's all for this session. Wait a minute. I will post the attendance link. You can fill the form and you can leave the session. Okay. 1 minute. Yes, you can fill the form and you can leave the session. Okay. Thank you. Yes, I've told you, right? So these are nothing but your representation, your type of representation. According to the, let's say, suppose if you, according to your requirement, if you have a maximum number of AND gates, okay. So what is the difference, key difference between them? Max terms both are crucial for designing and simplifying digital circuits by allowing for easy analysis. Yes, that is what. Yes. So someone has written very clearly. Yes. So when we are discussing about this particular sum of products, we will have majority AND gates, and so these are basically nothing but your type of representation of your particular circuits. Okay. So according to the requirement, according to your particular requirement, you can use this SOP form of representation or POS form of representation. Someone has written it very clearly. Once you can check it. Okay. Any other queries? Okay. So tomorrow we are going to see the simplification techniques. Okay. I wasn't able to attend last. Sure, sure. Okay. No issues in that. Okay. I think I already answered this particular question. No issue. When we are discussing came up, I will again address this particular question. Okay. When we are discussing gray code, I have said you that it is a unit distance code. Anyone remember why we are using K-map? Gray code in K-map? I've said right. So we are because it is a unit distance code, and we should map our adjacent cells. Yes, one bit difference. So adjacent means one bit difference. Yes, I will address this particular question again in tomorrow's session when we are discussing K-maps. Okay. Yes, I think. Yeah. Okay. Okay then. Our team will review it. Okay. No issue in that. Okay. Thank you. Good night.